Number 51, find the areas shared by these two circles. Let's begin with a graph. These are our two circles, and the area shared is shaded in yellow. Well, how to do that? Let's zoom in a little bit. Imagine this ray sweeping from 0 to, let's say, pi over 2 radians. As we sweep this way, if you let the blue curve be the end of the sector-like regions, but we have to sweep all the way until we hit this intersection point. After that, as we continue sweeping in the counterclockwise direction, we switch from the blue boundary to the red boundary. And we'll continue sweeping until we are tangent to the red circle, which means we'll be pointing at 90 degrees. So we'll be doing one area calculation for the blue boundary and then the other one for the red boundary. So we need to know where the blue circle and the red circle intersect each other at this point. When are the two radii equal? That'll be when the red circle's radius is equal to the blue circle's radius. If we divide both sides by 2 cosine of theta, then we have this equation. And we know that theta for this point is at pi over 4, because that's when the tangent ratio is 1. Okay, now we can take this ray and sweep it from pointing at 0 to pi over 4 with the blue radius, and then continue sweeping from pi over 4 to pi over 2 for the red radius. And that would give us all the area of the region shared by these two circles. So 1/2 radius squared d theta for the region with the blue boundary. And then when we rotate from pi over 4 to pi over 2, our radius will be the red boundary. Now we'll have to apply those double angle identities. Looks like that. And then continuing to do the integration. And wrapping it up, we end up with pi over 2 minus 1.